So we're going to have a look at recursive patterns. And looking at recursive patterns involves looking a lot more closely at the pattern rule and how those pattern rules work. So taking a look at this t-table and this input-output machine, one of the important things to note is that often by looking at a pattern that involves an input-output machine, that pattern will actually generate another pattern. So here we have the one pattern that comes from the input-output machine, times 4 plus 1. But that will actually generate another pattern. It will generate a pattern going down the output, a pattern of plus 4. And it's this pattern that comes from the common difference of each of the outputs. So 5 plus 4 is 9. 9 plus 4 is 13. Or if we reverse that, 17 minus 13 is a common difference of 4. It's this common difference that creates a second pattern. Now there's lots of words for this pattern, the pattern within the output rule. We would like to call it, though, a recursive pattern. And a recursive pattern is one where the value of one term is dependent on the one before it. Or a simpler way of saying that is the common difference. So let's look at another pattern. Here we have the pattern of 3, 10, 31, 94. How can we describe this pattern? There's no input-output rule because we haven't yet made a t-table. Well, we can multiply by 3. 3 times 3 is, 9. Not quite the second number of 10. 3 times 3 is 9, and then add 1. So we would have 10. Let's see if that continues to work. 9 plus 1 equals 10. Let's check out if it works. 10 times 3 plus 1 does equal 31. Does it work again? Yes, indeed it does. 31 times 3 plus 1 does equal 94. So what would the next three terms be? Well, we could multiply 94 times 3 and then add 1, and we would find out at least the next one, which would be 283. We would then have to multiply 283 times 3 and add 1, 850. And to get the third term, we would do the exact same thing again, times 3 plus 1. Finding a recursive pattern rule is not as hard as it looks. Here's a recursive pattern. 1, 6, 11, 16, 21. To find the pattern rule, find the difference between the terms. Here's the terms. If we find the difference, 6 minus 1 is a difference of 5. We want to see if that continues to work. Indeed it does. In fact, it works all the way along. So we do have our common difference. The common difference is a common difference of 5. The difference between each term and the previous one is 5. We just need to figure out how that happens. So perhaps it start at 1, add 5 each time. And for this pattern, that actually does work. To find the next three terms, we just have to add 5. And there they are. Try this one on your own. Can you figure it out? Pause the video, find the common difference, and then see how that common difference might be created. I'll give you a moment. Here's the common difference. Did you get 7? 13 minus 6 is 7. Does it work again? Uh-oh. We have a changing common difference. Each difference is 3 times the one before. That suggests that times 3 is part of the rule. 6 times 3 is 18. We're not quite there. So let's just try subtracting 5. Start at 6, multiply by 3, then subtract 5. Let's check. 13 times 3 minus 5. 34. It does work. Let's try some practice. Find the pattern rule, then extend the pattern 3 steps. Pause the video, try it out, and then check your answer. Pause the video, try it out, and then we'll check your answers. So, the first one, start at 2, multiply by 3, then subtract 2. Did you get 244 and then 732? I bet you've got this. What about the second one? Did you figure that one out? Let's see the answer. Is that what you got? You can do it. If you didn't, go back, see how I figured those two out.